All right, so we are back and we're going to finish it this time. And we're on page 5 out of 12, but that's okay because we're going to go. Oh no, we're page 4 out of 12. Oh well. All right. So I'm going to go fast and show you answers now. This is the same problem as that one. We just graphed this. Looks like so. We know what the intercepts are. They're right here. That's the y-intercept because it crosses the y-axis. This is the x-intercept. So find the slope of this line. Well, the cool thing about the slope is, what you'll notice is actually, if I want to solve it, we're going to do a little algebra really fast. This is ax plus by equals c, right? And we want to solve for slope. Now we're going to put it into that slope-intercept form. So for example, I can minus ax from each side. I don't know what a and x are, but I know that whatever numbers they are, I can subtract them from both sides of the equation. And I know that if I subtract them from the left side, they'll just completely disappear from that side. So then I'll end up with nothing on the left side except for by equals negative ax plus c. And that's what I end up with. Now, if I want to get rid of the b, I divide everything by b. So what does that look like? I'm going to have to write for this bit. I go to here, I go to here. I'm going to put the line right here. Line right here. Line right here. I'm going to divide everything by b. So it's going to look like this. B right here, B right here, and B right there. All right, this is going to give us a shortcut. It'll make sense in a moment. So when I divide by b, that leaves me with y on the left side equals negative ax over b plus c over b. I'm going to have to do that in 2 parts because we don't have the technology. All right, here we are. Boom, back to this. Now here's the cool thing. This right here, y equals mx plus b. This is y equals mx plus b. Why is that cool? Well, remember, the y equals mx plus b form. This is y equals mx plus b. There. M is negative a over b. Not 1a. And b equals c over b. The confusing thing is we're using some of these letters in each of these separately. So this b is like the y-intercept b from the last section. This b is part of this formula. Okay? So why is this important? Well, I can find the slope. It's going to always be negative this number divided by this number, always. So if I look at this number, I should have negative 3 divided by negative 2. So the slope is negative 3 divided by negative 2, or just 1.5. Take a look at what happens here. Or just 3 over 2 because the negatives cancel out. That's 1.5. And look at this. It goes over 2 and up 3. Over 2, up 3. So that's a way we can find the slope using just numbers. Everything about algebra boils down to just being able to say what the slope is. Slope is negative 3 divided by negative 2, or just 3 over 2, or 1.5. And one way we can do that, like I said, so I can put the 2 numbers in from here. Negative 3, negative 2. That's one way you can do it. Okay, you can also look at the graph, obviously. All right, create graphs of lines that match this description. Okay, let's do this. 2. Y-intercept of 10, x-intercept of 5. This is 1, 2, 3, 4, 5, 6, 7. Oh, I don't want that. I want to drag the whole thing down a little bit. The cool thing is once I've drawn it, I can scoot it around a bit. X-intercept's 5. Something more like that would be better. I'll just make it long enough now. Now the reason I did this is because I noticed that the y-axis, my y-intercept is 10, so I need to be able to count up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look at that, right up at the top. And the x-intercept's 5. 1, 2, 3, 4, 5. Right there. I'll mark them in another color. The larger dot. 6. And now I go back to a 4 or a 2. And I graph my line. Notice I'm not looking at the slope, I'm just looking at this point and that point, connecting them. That is what we do with standard form. Okay, now we have a y-intercept of 10 and no x-intercept. How am I going to do that? Let's think about that. I'll make my graph really fast. I gotta make sure it counts up to 10, so I'm going to make this down low so I can count up to 10. So my x-intercept is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, right there. Now, you might be able to think that you could go like something like this for my line. The problem is that since this line tilts, it's eventually way the heck out this way, going to cross the y-axis. They're going to meet eventually, right? As long as it's going down, it's going to meet eventually. But if it went up, see what happens if it goes up. If it goes up, you actually run into the same problem. It goes up, then eventually this guy is going to meet with this guy, and I'm going to have an x-intercept. I don't want to have an x-intercept. The only way I can do that is if it doesn't go up or down. It's the only possibility. So I need a line that goes like this. There's my line. It goes through 10, the y-intercept. It doesn't go up or down, so it'll never end up crossing this guy. It's parallel to the x-axis. All right, moving on to the next one. A line with an x-intercept of 5 and no y-intercept. All right, we're going to run into the same issue. If you want two lines to never cross, they have to be parallel. So I'm going to find my y-intercept right now. 1, 2, 3, 4, 5. There's my y-intercept. And if I want it to never ever cross the y-axis, then it has to be parallel to it, like so. The only option. Which of the graphs you created in question 15 are functions? Well, I will tell you that remember, functions are places where a point cannot be above itself. All right, so if I have something like this, then I plugged in an x. I got two different y's. Remember that from way back when. So what we're saying is, right here, if I tell you what x is 1, you can tell me y is 8. If x is 3, y is 6. If I tell you an x, you can tell me what y is. This one, if I tell you x is 5, can you tell me what y is? 10. X is 7, y is 10. X is 1, y is 10. So whatever x is, it gives me a y, which is always 10. Always. here's the problem. If I look at this one, I tell you x is 5. What is y? Well, y could be 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. I don't know what y is because it could be anywhere on this line. So x is 10. So this right here is problematic. Two of our functions. The last one is not. The first two are functions because based on what x is, you can find the value of y. The last is not a function. X is always 5, and y could literally be any number. Because if I tell you what's the point where x is 5, all of these have x being 5, whereas y is always changing. So I can tell you that x is 5, and that's all I can tell you. That doesn't tell me what y is. And remember, functions are when I tell you what the input is, the x, you should always be able to tell me what the y is. Okay, next up to each graph in 15, write an equation for the line that you graphed. All right. Now, we are going to, I'm not sure how far it wants me to go, but what we can do is we know y equals mx plus b, right? Y equals mx plus b. If I have my intercept and my slope, then I'm in good shape. This has a slope that goes down 2 and over 1, right? M equals -2. Because it goes down 2 and over 1. And then b, it crosses at 10. We know that. B equals 10. End up with y equals -2x plus 10. There we are. Just so you know, if I wanted to write it in standard form, it would look like this. 2x plus y equals 10. Okay? Either of these will work. Okay, this one right here. Horizontal lines have a slope of 0. So this one would be y equals 0x, or just y equals 10. There's no better way to write that. This will not have an x in it because it doesn't have a y-intercept, basically. All right, next one. Well, then this one is the same thing. It's basically all the places where x is 5, right? So the function for this is literally x equals 5, because all of these points are places where x equals 5. Y doesn't even matter. Y could be any number. It doesn't really matter what y is. X is always 5 on this graph. So you could have the point 5,1 or 5,2 or 5,3 or 5,4 or 5,5 or 5,6. If you're graphing it, all the points start with 5, and then the other number doesn't matter. All right, so we'll just say done. I'm going fast, I hope. Okay, graph the following lines. X equals 3. So I'm going to find all the places on my graph where x equals 3. Let's do that. I'm going to really quickly copy and paste this so that I don't have to draw it again. C, Control V. There. All right, so I have my graph now, and now I'm just going to make them. So I want all the places where x is 3. So like if I were graphing points, it would be like the points 3, 2, and the point 3, 4, and the point 3, 200. All the points where 3 is the first number, all the points where x is 3. And all of those points are going to line up to make a line that looks like this. Boom. All right, the next one. All the points where y is 4. So it could be like the points 1, 4. And the points negative 20, 4. And the point 35.3, 4. All the second numbers are 4. All of the y values are 4. If I graph all of those points, they all make a straight line that looks like this. 1, 2, 3, 4. All right. If I do this one, you're going to end up with all places where x is negative 5. So I'm going to find negative 5. 1, 2, 3, 4, 5 on the x-axis, and it's going to look like this. Try finding a point on that line that doesn't have x, the first number being 5. It won't happen. Y equals negative 2. Like this. All right. Oh, x is 0, y is 0. Those are actually the axes. So let's, I can still do Control Z, right? Control View. X, okay, good. There. All right, so now I'm going to find the point where x is 0. Well, that's all. This is where x is 0. Not to the right, not to the left. So if I graph this, it should actually be the line that goes like this. That's all the points like 0, 0, and 0, 5, and 0, 6, and 0, 8. This is all the points that where the second number is 0, and it makes a line that looks like this. So these are the points like 0, 0. Well, points where the second number is 0. So here we have all the points where the first number is 0. 0, 3, 0, 4, and so on and so forth. 0, 3 is right here, and 0, 4 is right there. All of the points where the first number is 0 go right there. All right. Complete the table for each line you create. Be sure to create a line, at least one vertical line. Okay, we're just going to do this. I want to see what's going on here. We got to go into here, I think. Oh, it logged me out. Gotcha. Just leave me alone. Algebra. We're going to use these ones. All right, so we're going to put in x equals 5, y equals 5, x equals 10, y equals 10. Yep. Sure. Yep. I'm going to take these guys, I'm going to type them in there. That's the easiest way to do it. Back to here. This is fairly arbitrary, I'm afraid. So we're just going to have some fun here. We're going to say y equals 6. So that it's better there. X equals 10. 2y plus 3x equals 6. No, we'll take 12. Go with x. That's probably good. Let's try a new one. For some reason, the size keeps changing on me. That's life, I guess. And we'll do 2x equals 3. We got um 5x, but y equals 2x plus 1. And then we'll do y equals negative 3x minus 4. And we'll do 5x 10y equals 50. There we are. I got them all. They're all in there. They're different sizes. Life goes on. Okay, so y equals 6. What's the point on the line? Well, that's any point where y is 6. Let's go with the point 36. The second number is 6, so it works. Another point on the line. I don't know. 2, 6. There we are. Slope, it doesn't go up or down. The height of it is always 6 up on the graph. So its slope is 0. All right, the next one, y equals 10. That's all the places where the first number is 10. So like 10, 3, or 10, 5, or 10, 17. It doesn't matter as long as the first number is 10. You're going to get a point that's 10 to the right, and 3 up, or 5 up, or 17 up. They're all 10 to the right though. And the line will go straight up and down, which means that this slope is what we call undefined or infinite. Then the line goes straight up and down. It's so steep that we don't even try to say how steep it is. It's straight up and down. I don't know. So that's the word we use when we're talking about a slope that's straight up and down, undefined. Okay, now this one right here. Now we said, let's have x in the front. I want to have x in the front so I can use a and b. All right, sorry about that. What is the point that works in here? Let's see. If I did the point, and remember, if you've got standard form, it's easiest to make the first be 0 and the second be 0. So if I make x be 0, this disappears and I have 3y equals 12. Well, 3 times 4 equals 12. So if x is 0 and y is 4, you'll end up with 3 times 4 equals 12. Now if I make y be 0, what we end up with then? Well, I know that if y was 0, this would disappear. And I end up with 2x equals 12. Well, 2 times 6 equals 12. So now if I plug the 6 in for x and a 0 in for y, that should work all as well. That'll make 12. This slope goes, let's see, 0, 4 is 4 up in the air. 6 to the right is 6 down. So it goes down 4 and over 6. Or just down 2 and over 3. In other words, the slope is negative 2 over 3. We learned that rule. I wrote it earlier. All right, this one right here. Okay, we got 2, 3. Let's see. If one of them is 0, if x was 0, now you can make a table out of this. If x was 0, y also has to be 0. How do I know that? Well, if I plug in an x for 0, this would be 0. 3 times what makes 0? 0. And then if x is 1, Actually, here's a cool trick. If I make x be 3, right? 3 times 2 makes 6. 6 is 3 times what? 3 times 2. So if I have one be this number, the other has to be that number. They switch places. Because 3 times 2 on the left side is going to make the same thing as 3 times 2 on the right side. That both make 6. So that works. What happens here? Well, this one has a slope of m. How would I figure this out? Well, if I solved it for y, I'd have to divide by these 2/3. If I solved it for y, I'd have to divide by 3. These would cancel out and get y equals 2/3 of x. Y equals 2/3 x plus 0. So I get a slope using y equals mx plus b form. Now this is in y equals mx plus b form, so I know the slope is 2 and the y-intercept is 1. Done, right? What are some points that work there? Let's try to pick some points. I know that if x is 0, if I plug in a 0 for x, that's the y-intercept, right? I end up with 1. Because that's the b, that's the y-intercept. There's a lot of stuff to remember, so you can go back and check if you're confused by that. My y-intercept is right here. It means if x is 0, then the y is 1. And then what if I make it be 1? 1. Well, if I plug in a 1, I get 2 times a 1 is 2, plus 1 is 3. 1, 3. Our slope is all right, this one right here also has slope-intercept form. So our slope is -3, and our intercept is -4. So right off the bat, I can go in and I can say, wait, then I know that if x is 0, then my y-intercept is -4. 0, -4. And then if I make that one bigger, 1, well, I know if I go 1 to the right, I'm going to go down 3. If I start at -4 and I go down 3, I'm going to end up at -7. Now I'm using this fast because I'm in a hurry. Life goes on. Yes, this one, standard form again. If x is 0, what do I get for y? If y is 0, what do I get for x? Well, if x is 0, that turns this to a 0. I end up with 0 plus 10y equals 50. 10y equals 50. Well, 5 times 10 makes 50. So y has to be 5. This side, however, we end up with, if y was 0, this would disappear, and I have 5 times x equals 50, which means that x would have to be 10. And there we go. The slope is negative a over b, right? So that's m equals -5 over 10, or -0.5. Okay, calculate the slope for each line. 0. Why? We've had a lot of these. The line is sideways. It's horizontal. This one is vertical. Slope is 1, 2, 5. Whenever you have something that goes horizontally, its slope is nothing. Write an equation for a line that has a slope of 0. Your answer could be anything, but it's going to be y equals something. I'm going to go with 2.5. Right, so what's that going to look like? Well, let's see if I can go back here and do the cut and paste, Control V. Yay. I'll scoot it down one more. So if I want to go 2.5, I would have to mark the point 2.5 on here. 1, 2.5 right there. I'm going to make it bigger. Boom, there's 2.5. If I want to graph that now, I just have to make sure I stay at 2.5 all the time, all the places for y is 2.5. It's all the places on the graph where y equals 2.5. Boom. Write an equation that has no slope. In other words, write an equation for a line whose value is undefined. That's what we talked about, undefined. That's the word we want. No slope, that doesn't make sense. There are other things. Yeah, we won't say no slope. We'll say an undefined slope. That's what you will say in later math. That's what we will say now. All right, so I'm going to go back to here. Control V. Boom. There. Okay. And my graph, well, I just need something where x equals something. Equals negative 1.5. Negative 1.5. We'll do that. I like the 0.5s right now. So what am I going to do? Well, I'm going to go in here. I'm going to find negative 1.5 on the x-axis. It's negative 1.5. It's right here. And then you have to make a line that goes straight through that. Like so. Notice an undefined slope goes straight up and down. That will always be true. Or I would actually say it backwards. A line that is straight up down has what we call an undefined slope. Okay. We're going faster now. Write an equation for a line represented by a graph or described in words, then determine the slope of each line. Okay, here's a line that they've got, right? It's going straight up and down. It's all the places where, notice, if I graph the points, this is the point. I'll make that smaller. This is the point negative 3, 4. Right? On the line, point negative 3, 4. Yeah. So I should completely understand. This is something that I could just tell you the answer, but it's very important you get what's going on. I'll tell you each of these points. All right. This point here is the point negative 3, 1. This point right here is the point, if I were graphing it, point negative 3, negative 1. This is the point negative 3, negative 3. All the points on this line, what do you notice the pattern of them? The x, the first number, is 3. That's why the equation for this is x equals negative 3. The slope of that is undefined because it goes straight up and down. We can't say how steep that is. Whereas this one clearly has a slope of 0. Okay. However, what's the equation going to be? Well, these are the points. Oh, this is always 1.5 up. So this is the point 1, 1.5, and 2, 1.5, and 3, 1.5. These are all the places where the y value equals 1.5. That's the function for it. That's the formula. That's all. Okay, the line is parallel to the x-axis and contains this point. Okay, so we want to be parallel to, we'll go to this one first, which is parallel with the y-axis. That means it goes up and down. So it's going to always have the same first number, isn't it? What first number do we want? We want the first number to be 5. So like 5.4 and 5.3 and 5.2 and 5.1 and 5.7 and 5.8. X always has to be 5. So x equals 5. That's my formula. Just like this one, x is always negative 3. And it'll be parallel to the y-axis, straight up and down. You end up with a slope of undefined because it goes up and down. The other one is parallel with the y-axis, this way. So I need my y to always be the same thing. What should it always be? 7. So I could have 3, 7, and 4, 7, and 5, 7, and 6, 7, and 7, 7, and it'll go to the right in a straight line. So I always want y to equal 7. And the slope of that is 0. All right, we're doing great here. Last couple pages. Oof, there's a lot. Okay. Points. I gotta go here. Gonna cut and paste some more. B. There. All right. So now I got my graph set up. And let's graph these. Okay. Here's the way I do it. Remember, first we plug in a 0 for x. Okay. What does that do? Well, that gives me the point. This turns to a 0. So I end up with negative 4y equals 24. And I ask myself, what times negative 4 makes positive 24? Y has to be negative 6. So I end up with 0, negative 6. That is 1 point. I'll make this one be, we'll make it be red. Okay, the other one is, what if I make y be 0? And then we've got, what if y was 0? So if y was 0, this guy would disappear. Negative 4 times 0 makes 0. So I end up with 3x equals 24. What times 3 makes 24? 8. So x has to equal 8. And I push enter, and this turns red, and I got. So, oops, Control Z, I don't want to turn it red yet. I want to say, so if x is 8 and y is 0, it also works. I'll make this one. We'll make that one green. So that's right there is the trick. So now I just have to take this 0, negative 6. 1, 2, 3, 4, 5, 6. Right there. And then this is 0, no, 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. So this point right here this guy is right here. And there we go. That's how we graph the line. I find the x-intercept and the y-intercept by making x 0 and y 0. If I make x 0, it finds the y-intercept. If I make y 0, it finds the x-intercept. It's just always the way it works. Okay, so I'm going to do the rest of them quickly. I just want you to see the steps. This one, I get these points. If I do these steps, I get these points. 0, if x is 0, y is 2. And if y is 0, x is negative 7. Negative 7 times 2 is 14, negative 14, and 2 times 7. Yeah, okay. We're going to go up here and we're going to make it the proper color because I don't want it to be green. I want it to be black. Okay, so I'm going to graph those 2 points and I'm done. 2, 0, 2. And negative 7, 0, 1, 2, 3, 4, 5, 6, 7. Hey, look at that right there. Okay, so the line is going to go like this. oops, Control Z. And there we go. Next one. These are my points. I'm going to graph. I'm going to have the point there. Okay, 0. If x is 0, then 3. Y has to be -5. And then -3, 0. Those are my 2 points if I go through this process again. This one, if I go through that process, I get the points. 0, y is, oof, it takes 2.5 eighths to make 20. So it's going to be 0, 2.5. And 5, 0. There. Those are my points. I'm going to graph them really fast for each of these, and then I'll have my lines. Okay, so 0, -5 is 0, -5, 1, 2, 3, 4, 5. And then -3, 0 is right there. And 5, 0 is 1, 2, 3, 4, 5, 0. And 0, -2, 0, 2.5 is 1, 2.5 there. Okay, so now I just have to change the size, change the color, and we're set. So like this. There's that one. And there's that one. Boom, we got 2 lines. Okay, last page. Ooh, this takes forever, doesn't it? Sorry. All right. Points are 0. X is the, oh, this is in the other form, isn't it? Y equals mx plus b form. I don't have to do that anymore. I'm going to do it a different way. And this is the thing. If you have y equals something, 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 then you're going to use the slope and intercept. Here, this is the fastest way, because what is the slope of that? What is its y-intercept? Well, I can figure out the intercept and I can graph it quickly. Whereas this one, I could do the same thing, just for the record, but some of the intercepts might not be so pretty. So instead, I know that this is the y-intercept, and that's the slope, right? So I'll make my y-intercept right here. And the slope means it goes down 4 and over 1. Over 1, down 4. Like so. I hope you see I'm doing this quickly because the goal of this whole thing is to be able to do this quickly, to know how to do this without working too hard. So -3, my y-intercept, okay, it's right here, and it goes down 4 and over 5. And there we have our line. This is -3, and it goes down 4. And over 5. And yellow. 4, 5, down 4, over 5. That's how I get those numbers. Remember, this is y equals mx plus b, but this one's not. This is x and y on the left side. It's in standard form. So I'm going to go back to finding y-intercepts and x-intercepts. Points are 0, x is 0, y is 6. And if y is 0, x is 4. Here we have 0 is 6. No, 8. Y is 0, x is -6. I'll graph those 2 points and we'll be set. 0, 6, 1, 2, 3, 4, 5, 6. 4, 0, 1, 2, 3, 4. -6, 0. And 0, 8. Oops, it's up there. Good enough. All right, I'm going to change that to a 2, and we are done. Just gotta start from there. And there you go. That's the whole thing. Have a wonderful, wonderful time graphing more and more and more lines. The whole goal is to do this fast and get better and better at it, because graphing lines should be something you do easily later in high school. Like, oh yeah, that line, I'll just graph it real fast. Okay? So good luck.